Welcome. Today we'll explore how digital twins are revolutionizing green hydrogen production. These predictive virtual models are cutting costs and optimizing performance, turning complex facilities into efficient, data-driven operations. A digital twin is a real-time, dynamic virtual replica of a physical system. Leveraging sensors, cloud platforms, and AI, it predicts outcomes and acts as an operational control tower, providing deep insights for strategic and tactical decision-making. Green hydrogen facilities face tough challenges. The input from renewables fluctuates. Water quality varies. Environmental conditions can be harsh, and equipment is expensive. Overcoming these with digital intelligence is becoming essential. How do digital twins work? They gather data from IoT sensors across assets, send it to cloud platforms for processing, then apply AI analytics. The system delivers actionable insights, helping companies optimize operations and preempt failures in real time. Digital twins enable real-time monitoring of critical parameters like temperature, pressure, humidity, voltage, flow rates, and gas purity. Going beyond traditional SCADA dashboards, they provide predictive insights, allowing proactive handling of anomalies. Maintenance is often reactive and expensive. With digital twins, facilities shift to a predictive approach, identifying potential failures early, scheduling targeted interventions, and minimizing both downtime and costs. Here's a real example. At a German hydrogen facility, digital twin simulations revealed inefficiencies in gas compression due to colder spring temperatures. As a result, the plant trimmed energy waste by 14%, cut maintenance by 30%, and achieved full optimization in just 1 year. To implement digital twins, robust data infrastructure is needed. IoT sensors collect operational data, a centralized cloud platform processes and stores it, and AI or machine learning tools model the system, continuously adapting to new real-world conditions. Quality sensor data is crucial. Facilities must ensure the right sensor types are in place: temperature, pressure, flow, and more. Data quality is safeguarded through regular calibration, redundancy, and integrity protocols to maintain confident decision-making. Several leading platforms support digital twins in hydrogen, such as Siemens NX, Aviva, Ansys Twin Builder, and Microsoft Azure Digital Twins. Advanced features like augmented reality overlays allow on-site personnel to visualize and interact with virtual models directly. These technologies deliver proven ROI, up to 40% reduction in unscheduled downtime, 10 to 25% improvement in energy use, 20–30% lower annual maintenance costs, and payback in only 18 months. All results have been validated by comprehensive analytics and third-party verification. What-if scenario modeling is another digital twin advantage. It enables strategic planning, testing equipment investments, optimizing capacity, and evaluating process tweaks before they happen. So decisions are data-driven, risk-aware, and impactful. Key challenges remain: ensuring data quality, integrating with legacy control systems, and addressing the skills gap. Reliable data, updated platforms, and qualified staff are critical for effective digital twin rollouts. Successful digital twin strategies require new technical skills, deep hydrogen process knowledge, data engineering, AI and machine learning, integrating diverse systems, and advanced IoT sensor management. Meaningful workforce training programs are vital to realize the full potential of digitalization. Measuring success is essential. Facilities set targets for increased plant uptime, improved energy efficiency, reduced maintenance spending, and faster issue resolution. Early adopters enjoy a strong competitive edge and measurable performance benefits. Beyond individual plants, entire hydrogen supply chains can be modeled. System-wide digital twins capture wind-powered electrolysis, hydrogen pipelines, and storage, with features ranging from regional load balancing to real-time tracking of carbon emissions. At the ecosystem level, these solutions coordinate hydrogen production with shipping logistics, vehicle demand forecasts, and even carbon credit opportunities, delivering comprehensive, AI-driven intelligence for all stakeholders. Is your facility ready? A digital twin readiness checklist covers assessing infrastructure and ensuring operational readiness. so implementation efforts are focused and effective. In summary, predictive operations powered by digital twins outpace traditional reactive approaches, driving down costs, improving uptime, and offering a decisive competitive edge. Now is the time to build your digital twin strategy. Thank you for your attention. For more details, see the link to our digital twin implementation checklist. We welcome your feedback, especially on areas of your facility you'd like to simulate before making changes. Let's transform hydrogen production together.